Hello, pre-calculus students. Mr. Brooks here. Today we are going to go over lesson 4 from the logarithms unit. I'm going to go through all of the problems in the lesson in one video, so feel free to pause, rewind, or fast forward as you deem necessary. Let's start with the first do now. 3 to the 2x minus 1 equals 27. First job is to put both sides of this equation in terms of the same base. 27 can be written as 3 cubed. Now that we have both sides of the equation in terms of the same base, you simply set the exponents equal to each other and then solve for x like you would any other algebraic equation. X is 2. For problem number 2, we have 4 and 64 on the right side. Both of them can be written in terms of 4. Left side is 4 to the x minus 1. Be careful on the right side. 1 over 64 is the same as 4 to the negative third. Again, since the bases are equal to each other, you set the exponents equal to each other. X minus 1 equals negative 3, and you solve for x, which is negative 2. Moving on to the logarithmic equations, the first example, we have log base 3 of 4x minus 7 equals 2. We are first going to convert this equation from logarithmic form to exponential form, which would be 3 squared equals 4x minus 7. 3 squared is 9. And again, it's a basic algebraic equation that we are solving for x, which is 4. Example number 2 is very similar. X squared equals 64. And to isolate x, you want to take the square root of each side. Now, x here is only 8. Why is x not plus or minus 8? One of the log rules that you need to remember is the base of a log must always be positive. So we're taking only the positive root here, which is 8 as opposed to negative 8. Moving on, there is a new rule, property of equality for logarithmic equations. What that's telling us is if the left side of an equation equals the right side, and both sides are have the same base, then you simply set their arguments equal to each other. So for instance, example 3, the left side equals the right side. The base of the log on the left is the same as the base of the log on the right, so you simply set their arguments equal to each other. 5x minus 1 equals x plus 7, and when you solve for x, it equals 2. Moving along, for the problems in example 4, we need to use the log rules that we've already learned. So example A, both logs are in terms of the same base, and we are adding. Well, addition in log terms means we multiply. So what we're going to do is write log base 9, multiply x and x minus 8 to get x squared minus 8x, and you set that equal to 1. Converting this from logarithmic form to exponential form, we take 9 to the first, or just 9, equals x squared minus 8x. This problem is a quadratic because there is a squared term, so you set equal to 0. X squared minus 8x minus 9. You either factor or use the quadratic formula. Factoring is easier. So negative 1 does not work, and only 9 does work. Problem B, we are subtracting, which in the world of logs means division. Log base 4, x plus 8 over 2 equals 1. Again, I'm converting it from logarithmic form to exponential form. 4 to the first, or just 4, equals x plus 8 over 2. And here, it's just a basic algebraic equation. Solving for x is 0. Now, x can be 0 because when you plug 0 in here, you are still taking the log of a positive argument. Part C. This problem is a little bit different. We are using natural logs instead of regular logs. The approach, however, is still the same. Remember, natural log is the same as log base e. We are subtracting here, so that's the same as, that is the same as division. Natural log of x equals natural log of x plus 6 over x minus 4. You set the arguments equal to each other. X equals x plus 6 over x minus 4. When you clear the fractions, you get another quadratic. X squared minus 4x equals x plus 6. When you set it equals 0, x squared minus 5x minus 6 equals 0. You then factor or use the quadratic formula to solve for x. X is 6, or x is -1. Again, -1 does not work because when you plug it back into the original problem, you are taking the natural log of a negative number, which you cannot do. Continuing with the problems on the back, practice problem number 1. Again, convert it from logarithmic form to exponential form. Go with green. Both sides can be written in terms of base 3. And remember, when you raise a power to a power, you multiply the exponents, and we are going to set the exponents equal to each other in the same step. 4x plus 2 equals 3. Solve for x 1/4. Problem 2. Again, write both sides in terms of the same base. Left side is 2 to the 6x. Right side is 2 to the -4th. Exponents equal. Solve for x. Problem 3. Both sides in terms of the same log, so we set the arguments equal to each other. Solve for x. Problem 4. Same base. We are adding, which really means multiply. Convert it from logarithmic form to exponential form. 64 is 8 squared. Solve for x. 73 over 3. Moving on to problem 5. Again, logs are in terms of the same base. And we are subtracting, which means we divide. Left side equals right side. The bases of the logs are the same, so you set the arguments equal to each other. Cross multiply and x is 2 for number 5. Problem 6, we're subtracting, so we're going to divide. Convert it from logarithmic form to exponential form. Solve for x. We get 2 answers this time, plus or minus 7. When you plug either value back into this argument, you get a positive argument. So that's why both values of x, the positive and the negative value, work. Problem 7. On the left side, we are dividing. The base of the left side equals the base of the right side. What we are also going to do is simplify this fraction. Make sure you simplify it correctly so it turns into n plus 1, right side 3n minus 1, solve for n is 1. To go over that in greater detail, if we factor an n out of the numerator, that's how we can simplify the two n's, and we end up with n plus 1. Problem 8, what we need to do is get rid of that negative 6 first by dividing both sides of the equation by negative 6. And then we convert it from logarithmic form to exponential form. 3 to the 4th is 81. And our answer is x is 84. Final problem. Again, we are dividing because there is subtraction. Convert it from logarithmic form to exponential form. Cross multiply, and it turns into a quadratic, so we have to set it equal to 0. Factor or use the quadratic formula. Here, both values of x work. Again, when you plug them in, both values give you a positive argument there. Both values give you a positive argument in the first part of the problem. So those are all the problems for solving logarithmic equations.